This is the prep packet video for Unit 4, Chapter 9.7, Objective 2, where we work on solving an equation with one square root. So sometimes we have to square a binomial in order to solve a radical equation. So let's take a look at this example. We have the square root of 2x plus 1 equals x. We have x's on both sides, and we have to take care of this radical sign first. So let's do that. So I can rewrite this as I can rewrite it by first of all subtracting that 1. So now I have the square root of 2x plus 1 equals x minus 1. And now I'm going to square both sides to get rid of the radical. So by squaring a square root sign, I just end up with what was inside all by itself. And here I'm going to use what I remember about squaring. If I have a minus b squared, it's the first term squared plus the last term squared, and in between is this times 2. So 2 times ab, and because b is negative, that's negative. So up here, you can FOIL it if you want, but I want you to work toward using what you know about pattern recognition to do the easy work. So this is going to be x squared, negative 1 times negative 1 is positive 1, and the middle term will be this times 2. So negative 1 times x times 2 would be negative 2x. So once I'm at this point, now I can just solve my equation by getting all my variables on one side and all my constants on another. Oh, but wait, I have this going on. So maybe it's going to turn into a quadratic equation. Let's see what happens. We'll use blue now. I'm going to work toward quadraticness, so let's see what happens. First I'm going to subtract this from both sides and this from both sides. And that'll be 0, and that'll be x squared minus 4x equals, oh, and that's 0. So I have it's sort of an incomplete quadratic, so all I'm going to do here is pull out the common factor, which would be x. Equals 0. And this tells me that x equals either 0 or 4. And what I'm going to need to do is I'm going to need to check my work. So let's see if this will work. So we're going to check our work now to see if there are any extraneous solutions. In the last slide we had x equals 0 or x equals 4. And now I'm going to use the original equation and plug these values in to see if it's still true. So let's see. The square root of 2 times 0 plus 1 equals 0. So the square root of 1 plus 1 equals 0. 1 plus 1 does not equal 0. So that's an extraneous one. Let's check this one. The square root of 2 times 4 plus 1 equals 4. So 2 times 4 would be 8 plus 1 would be 9 plus 1 equals 4. 3 plus 1 equals 4. So this is a solution to that original equation. So your answer would be that. Do not include 0, and do not be satisfied with just getting to this point and thinking you're done. You have to check your work. Okay, let's do one more. So here we have a radical on one side, and we have a constant, and then we have a variable on the other. First of all, I'm going to isolate the radical. So I'll end up with the square root of 2y plus 4 equals y minus 2. Then I'll square both sides, and this will just be 2y plus 4 equals y squared minus 4y plus 4. I'm going to isolate. I have that second power there, so I know I'm going to have a quadratic, so I'm going to subtract 2y, I'm going to subtract 4, and here I'll have 0 on this side, y squared minus 6y, and then plus 0. So this is similar to the last one we did, so we'll have 0 equals y times y minus 6. Y equals either 0 or 6. So we'll be checking that one. So here let's check it if y equals 0. So I'm going to plug that in. 2 times 0 plus 4 minus 2 equals 0. And that's the square root of 4 minus 2 equals 0. The square root of 4 is 2, and 2 minus 2 does equal 0. So that one's okay. Let's check it if y equals 6. So here we have 2 times 6 plus 4 minus 2 equals 6. And that would be the square root of 12 plus 4 minus 2 equals 6. The square root of 16 minus 2 equals 6. 4 minus 2 does not equal 6. So this one is extraneous. And this one is not. So your solution set would be 0. So I want you to go get some more practice and do the practice you tries on page 580 and include them with your prep packet.